Hey, what's going on? This video is going to cover chapter 3.4 from the geometry textbook. A lot of what we're going to do has to do with perpendicular lines and perpendicular segments. So questions 1 through 4 want us to find the distance from point A to the line BC. Okay, so point A, let's go ahead and color that pink. And then the line BC, and we'll color that yellow. Okay, so what is the distance, right? Now, if you look here, right, there are actually 3 different distances that are labeled, right? The distance from A to point B on the line, the distance from A to point D on the line, and the distance from A to point C on the line, okay? Now, a question like this, even though it just says find the distance, what it really means is it means to find the shortest distance. Okay, and the shortest distance is going to be the one that is perpendicular. Okay? So for us, the shortest distance is going to be that green segment right there. Now, it would be nice if we could just count the number of grids to figure out how long that green segment is, but because the green segment is diagonal, we can't just count it. Right, so we have to use, you can use the distance formula, or I like to use the Pythagorean theorem. Okay. So that green distance has a horizontal, vertical component to it. It's 2 units horizontal and 2 units vertical. Okay. And so we can say, we know that a squared plus b squared equals c squared. I'll use c to represent the length of the green segment. Okay. Right, so this is going to be 2 squared plus 2 squared equals c squared. That's 4 and 4. So that's 8 equals c squared. And then we can take a square root on both sides. And we can just say that c is equal to the square root of 8. If you want, you can write that as what? It's root 2. Or if you want to write it as a decimal, it'd be approximately 2.8. Okay. All right, so the other 3 questions here are all kind of similar, so I'll try to go through them a little bit more quickly. Okay, so the shortest distance, again, is the segment that is perpendicular. So I'll highlight that one in green. Okay, and so let's just call that C. Okay. Maybe I should call it D for distance, whatever. All right, so I want to find the distance of that green segment. Okay, and I'm going to use the Pythagorean theorem to do it. All right, I'm going to break it up into a horizontal and vertical component. And it looks like this is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay. So a squared plus b squared equals c squared. So I'm going to plug in 6, 6, and d. 6 squared plus 6 squared equals d squared. That's 36 and 36, so that's 72 total equals d squared. And then we can take the square root on both sides. So we can say that d equals the square root of 72, which is approximately 8.5. Sorry, I was doing most of that off screen. Didn't realize that. Okay, problem number 3. Okay, the distance is going to be the shortest distance, which is the perpendicular segment. Okay, and then we'll go ahead and use good old Pythagorean theorem. Okay, 1, 2, 3, 4 units horizontally and 2 units vertically. And let's go ahead and label the green segment as D, since it represents the distance, the shortest distance between the point and the line. Okay, so 4 squared plus 2 squared equals d squared. That's 16 plus 4, so 20 equals d squared, square root both sides. And so d equals the square root of 20, which is approximately 4.5. And then the final one here, the shortest distance is going to be that perpendicular segment. And we can, again, separate it into a horizontal and vertical component. That's 2 units horizontally and 1 unit vertically. And I keep forgetting to label my distance as d. So a squared plus b squared equals c squared. 2 squared plus 1 squared equals d squared. That's 4 plus 1, 5 equals d squared. Square root both sides, so d equals the square root of 5. And that is 2.2 approximately. So that's how all of those problems are done, okay? If the question asks for the distance, what they really mean is the shortest distance, right? And so you need to find the length of the perpendicular segment. And since all of these perpendicular segments, I'm looking at the ones here in green, since they're all diagonal, we have to use the Pythagorean theorem to find the distance. You could also use the distance formula, which, I don't know, I'm not the hugest fan of it. The distance formula says take the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so you need to find the difference in the x coordinates, square that difference, find the difference in the y coordinates, square that difference, add them together, and then take the square root. Okay, the distance formula is actually based on Pythagorean's theorem. So, and for me, I just find Pythagorean's theorem easier because all I have to worry about is 3 things, right? A, B, and C. Whereas for the distance formula, there's actually 5 things: d, x2, x1, y2, y1. So I'd rather use a formula that has 3 variables than a formula that has 5 variables. That's just me. Here's the other type of problems that we're dealing with in section 3.4. Diagrams that have intersecting lines, and we need to figure out which ones are parallel. Okay, so which lines are parallel? So in diagram 5, we have 3 intersecting lines, and we know 1 angle, right? So there's a right angle here. Okay. So that tells me that line P and S are perpendicular. Okay. The question is, which lines are parallel? Okay. Now, to the casual observer, you might say, oh, well, P and Q look like they're parallel, right? They both look vertical. But the truth is, we don't exactly know any of these angles, right? Yeah, they kind of look to the casual observer like they might be 90-degree angles, but they might be 89 degrees or 91 degrees. So without the actual square symbol there, we don't know for sure whether any of these angles are 90 degrees. Okay, so for diagram number 5, well, we can't say anything, right? I can't say for certain if P and Q are parallel. They look like it, but without knowing one of those 4 angles, I cannot say for sure. Right, diagram number 6. So here we've got 4 intersecting lines, okay? And we know 2 angles, right? So we have a right angle here, 90 degrees. We have another right angle there, 90 degrees, okay? Those happen to be corresponding angles, right? They're in the kind of top position at these 2 points of intersection. Okay. Now you might remember we have a theorem, or actually a converse, that says if the corresponding angles have the same measure, then the lines must be parallel. Okay. And so we could say that lines P and Q are parallel, and line R is going to be the transversal, and then those are the 2 corresponding angles. So we can say P is parallel to Q because of the corresponding angles converse. Now, can we say that S and R are parallel? Well, again, to the casual observer, they might look like it, but we don't know any of the angle measures at that intersection, and we don't know any of the angle measures at that intersection either. Okay, so there's really nothing we can say about R and S. All right, in diagram number 7, okay, so now we've got a right angle there and a right angle there, which technically, if this angle is a right angle, then the other 3 angles at the intersection will be right angles as well. Okay, this will be 90 degrees because of vertical angles, and this will be 90 degrees because it's the linear pair. Okay, so at any intersection, if one of the angles is 90, then all 4 of the angles are 90 degrees. So we can say that all 8 of those angles are 90 degrees. So once again, we have 90 degree in the top right. This is also 90 degree in the top right here. So corresponding angles are congruent. So for this, let's see, J and K are going to be parallel. And the reason is because of the corresponding angles converse. And now, what can we say about lines M and N? Okay. Well, now we do have some more angle measures in this picture. Right? We have another 90 degree here. Okay, and this was a 90 degree there. So both of these angles are 90 degrees. They're both in kind of the top right position, right? So that's, again, another set of corresponding angles, right, that are congruent. So we can say that this is going to look a little messy. Lines M and N are parallel because where we have this orange transversal, we have 90 degree measures in the same corresponding position. So M is parallel to N, again, because of the corresponding angles converse. And that brings us to our last problem, number 8. And so we have a right angle here, a right angle here. So actually, technically, we have 4 right angles at that intersection. We have 4 right angles at that intersection. And at this intersection, we have angle 1, angle 2, but they both are marked. And this mark means that they're congruent, right? So angle 1 is congruent to angle 2. Okay. Now, angles 1 and 2 also have to add up to 180, right, since they form a linear pair. So the only 2 angles that could be the same and still add up to 180 are 90 degrees and 90 degrees. Okay, so that's 90 degrees, that's 90 degrees. Actually, we have 12 known right angles in this picture. 4 right angles here, 4 right angles here, and 4 right angles here. All right, let's see if I can do this a little bit more cleanly. So since, let's say, these 2 angles are both 90 degrees, that would imply that lines M and N are parallel. Okay, so M is parallel to N, right? Because those 2 angles are, again, corresponding angles. And similarly, we could say, like, here's a right angle in the lower right position. Here's another right angle in the lower right position. Okay. And that would imply that lines S and T are parallel, again, because we have two corresponding angles that are congruent. Okay. So S is parallel to T, again, because of the corresponding angles converse. Okay. So for all of these diagrams, I used corresponding angles to show which lines are parallel. Okay. You just need to find two right angles in the same position. Right here, I have two right angles in the kind of top position of the intersection. Here we had, well, I don't remember what I used, so let's go to this one. Here I had the blue ones, two right angles in the top left position, and then here I had two right angles in the bottom right position. Okay, so if you find any corresponding angles that are congruent, right, you know that the lines where those corresponding angles are going to be parallel. Okay. All right, thanks for watching this video. I'll see you guys in the Zoom meeting.